Welcome to the Doherty Water for Food podcast. Since 2010, the Doherty Water for Food Global Institute at the University of Nebraska has worked toward one goal, a food and water secure world. One in which global food security is ensured without compromising the use of water to meet other essential human and environmental needs. It's a daunting vision, but one that is vitally important. This podcast amplifies the voices of those making waves in this space. We hope you enjoy today's episode.
Hello and welcome back to the Water for Food podcast. Today we're taking a closer look at a topic that has generated both excitement and skepticism in agriculture, carbon credits. Can farmers be paid for storing carbon in their soils? How do we know that carbon is really there? And what kind of science is needed before carbon credits can become a trusted tool for producers, policymakers, and investors? To help answer those questions, we're joined today by Christopher Neale, DWFI Director of Research, who has been involved in a U.S. Department of Energy-funded project to validate carbon sequestration in Midwest corn production systems. The project has spent 5 years collecting field data, measuring greenhouse gases, and helping establish the scientific foundation behind agricultural carbon markets. So welcome, Christopher.
Yeah, thank you. Good to be here.
Yeah. So for our listeners who may not be following carbon markets closely, what exactly is a carbon credit and why has agriculture become such an important part of the conversation around them?
Okay, well, I'm definitely not an expert in the carbon market, but as I understand it, if there's a system out there where if you can show that you're capturing carbon, you can get credits, and there's an international network that's involved. And we've been working on measuring and modeling the whole carbon cycle in agricultural fields in the Midwest, specifically that produce grain for the ethanol industry. That's what the DOE, Department of Energy, funded us to do. And there's other universities and groups that are working on different parts, but that's what we got funded to do.
Why are cropland soils viewed as a potential climate and carbon solution? So can you explain a little bit in layman terms how that works?
Sure. Agriculture is one of the activities that can either produce carbon and emit into the atmosphere, but it also is the activity that has the largest potential for capturing, one of the largest potentials for capturing carbon. And so the project precisely is, we had, as I explained, fields that were supplying, that representative of thousands of acres that are providing grain for the ethanol industry, and in different types of production systems. So here in Nebraska at Meade, one of our fields is an irrigated corn-soybean rotation, direct planting. And the other two fields, one's in Iowa, which is rain-fed, but also corn-soybean, but it has cover crops. That's another type of production system. And then the third field was in Morris, Minnesota, also corn and soybeans, but in a different climate, colder in the winter, etc., right? So what the DOE was interested in was they have models, life cycle analysis models, that you calculate how much carbon is going in from all the inputs, right? Tractor diesel, electricity, fertilizer, and the carbon that it took to produce that, how much is applied, and how many times you pass with a tractor. In the case of irrigation, how much pumping and electricity goes into that, right? So we look at all these inputs And then we look at the outputs, right, which is the grain, right? There's the plant captures carbon and stores some of it in the grain. And so we look at the yields and the spatial yields and all that. So we were doing measurements to measure all the greenhouse gases through eddy covariance technology that measures CO2 and water vapor. But we've added, we got funded from the DOE to add additional analyzers to measure methane and nitrous oxide, which are very potent greenhouse gases that are emitted or absorbed in agriculture. Nitrous oxide, for example, is a result of nitrogen fertilization, right? And it is released in the process, and it's a potent greenhouse gas. So it's got to be taken into account. So what we've been doing with our measurements are using the measurements in the models with all these other inputs to calculate how much carbon is sequestrated in a cornfield in a typical year, and then in soybeans and in the rotation corn and soybeans.
That sounds very complicated. Well, we mentioned carbon markets earlier, so I think a lot of people hear about carbon credits as financial instruments or market mechanisms, like you mentioned, where you may be getting paid for carbon credits and that sort of thing. But in order for those markets to function correctly, there has to be confidence in the science behind that what we're saying is being measured is actually accurate. And I think that's where your project comes in. So can you tell us about when the project started in 2020, talk a little bit about how that came to be, anything surprising that has happened in those 5 years, and
Sure.
how things maybe have changed too, and then also why focus on corn in the Midwest?
Right. So the very first activity of the field activity was to do deep core soil sampling, okay, to establish the total carbon stock in the soil before the experiment started. Okay. And carbon gets captured in the soil, but it's a very slow process. So we did this down to 1.2 meters, the root zone depth of corn. We did soil sampling to measure that total carbon stock at the beginning, and now we did it now at the end, 5 years later, and we to hope to see the difference. And that's the carbon credit that the eventually the farmers are going to get, right? To show that they're capturing carbon in the soil and it's increasing, and they get paid for it. And what we've been examining is these different production systems, is what production system is more efficient in capturing that carbon. And you asked for some surprising results. Is for example, in 2021, we had a record-breaking year here at Meade, Nebraska, at our research field, where we actually broke the yield record, 18.5 metric tons per hectare. Sorry, I'm going SI units on everyone. That was a record-breaking yield, and it showed on our carbon measurements, right, that we captured a lot of carbon that year. But then what we learned is the next year, which is soybean, we actually lose carbon, or we emit more carbon into the atmosphere. One is soybean is a C3 crop. It doesn't capture carbon as efficiently as C4 crops like corn and grasses. And two, the fact that it's minimum till, we learned that the corn stover that stays on the surface, and there's the direct planting of the soybeans through that, that corn breaks down during the soybean year and it emits carbon, CO2. So So there's in the second year of this rotation, we lose carbon from that corn stover, and the end result of the 2 years, that's what's important, is the rotation, is there is carbon capture, but much less than just the corn year alone. So that was a surprising to learn that.
Yeah, that's interesting. So when the carbon is, I'll say, absorbed into the soil, how long does it stay there, or what happens to it? You said that then when you're growing soybeans, you're losing carbon from. Is that
well,
from the soil,
not necessarily that's from the whole system.
Okay.
In fact, one thing to point out is we've only just done the final carbon soil stock sampling at the end of the project. So now we're going to compare these results with the ones we did 5 years ago to see how much was captured in the soil, because we haven't taken that into consideration in the model yet. Okay. We've been just doing what's being emitted and what's being captured through the grain and the production and all that, right?
And that's done through those flux towers that you mentioned.
That we've been doing through the flux towers.
So there's a different measurement that you take through the soil, and you
yes,
can see
and
the,
now
the
we're going
long-term
to
5 years.
yes, now we're going to do it for the long term and see how much over a 5-year rotation of corn soybeans, how much we did capture, and how it differed here and in Minnesota and in Iowa, because one of the Iowa, they have a cover crop, which means they plant a cover crop and that greens up after the corn is harvested, okay? And what that does, it helps capture some of that extra nitrogen that's still in the soil, okay? And capture and produce biomass from it. Why? Otherwise, it gets broken down and emitted as nitrous oxide, which is a potent greenhouse gas. So in our calculations, nitrous oxide emissions needs to be turned into the carbon equivalent and factored into this carbon balance, right? Another thing we learned that was surprising is that methane actually gets captured in a typical corn soybean rotation. That was a surprising, and we measured that through chambers, automated chambers that are under the canopy, measuring the emission from the soil directly. Okay, so and those have gas analyzers that are measuring nitrous oxide and methane and CO2.
Well, my next question was, why is measuring soil carbon so challenging? But I think you just answered that for us.
Yes.
Does the soil carbon vary from like one part of a field to another, or is it pretty consistent as long as it's the same cropping?
It can vary,
okay,
depending on the soil physical properties, right? Whether it's a more clay, loamy soil compared to a more sandy soil. So though the physical properties not only affect the way the soil holds water, right, which the crops need to grow, but also the way it holds nutrients and captures carbon. So there can be variability in the same field, indeed.
So what type of soil is best for capturing carbon? I assume not sandy soil, right?
Yeah, it's more clay, loam type soils, right? Yeah.
So that's where maybe you might see a difference in your Minnesota plots as opposed to Nebraska.
Yeah, well, that and the fact that they are not irrigated, so their yields are lower, because one advantage of irrigation is you can use hybrid varieties and plant them at high density, and that increases the yield because you're supplying the water. But in a rain-fed situation, the planting density might be less, right? And the yields are lower.
So are you saying there's more like biomass that's available for the carbon sequestration?
Exactly.
Okay. Now I'm speaking your language. What do you think are the biggest sources of uncertainty when measuring for carbon credit?
Well, I think what we've learned is the GREET model, which is what the DOE adopted, and what we've been testing our measurements against, has default values in there. If you don't have measurements, it says, okay, you're in this type of soil and you're doing a corn soybean, this is the default value for emission or for biomass or whatever. And what we found is that after we incorporated the measurements, the results are very different from what the model without these inputs would be. So that's what the DOE wants to learn, right, with all these measurements, is how to better adapt the model to the reality in the field and make it more realistic for the future, right? And so that it can be modeling future situations better for the carbon credit market.
So what are some of those variables that you're building into that model? You mentioned the soil type.
Well, the emissions from the soils, right? The nitrous oxide and methane and CO2, those measurements. And then, with the eddy covariance, those are the default values were just not representative of what we found in the field, right?
Interesting. So how do you distinguish between real carbon gains and what you might expect in normal variability in an agricultural system, like in order to prove that with a certain level of confidence that it's absorbing the carbon?
Yeah, that's a very good question and a challenge, and especially because, as I mentioned, the soil carbon capture is a slow process, right? So if we did these measurements of total soil core carbon that we did in the beginning and in the end of the project after 5 years, if we did them every year, it would be noisy, right? The variability and the noise and the data wouldn't show that there was any, what was captured is within the noise. Now with 5 years, we'll be able to actually see what was captured, right? And take those values into consideration along with all the other measurements. And the other area where capture occurs is in the biomass and in the grain, right? And that grain leaves the field, right, to go and be processed for ethanol or food or feed and so forth, right?
So let's pivot a bit to farmers that might be evaluating these carbon programs and if they should participate. What would you tell them about the science today and what they should consider?
Well, I think that eventually the Department of Energy wants to offer these credits to the farmers based on what we've learned from all these research. Remember, we're just one of the groups. There's other groups looking at other crops in different parts, rice and so forth. So they want to be able to say to the farmer, look, you're doing corn soybean, okay, this way, but we know that if you do it this other way, you're going to capture more carbon, and we're willing to pay you to do that in this other way. So I think that's how it's going to be used in the future. And then there'll be soil sampling and modeling to make sure that they did what they were supposed to and that the field was actually capturing carbon. Mm-hmm. So I don't know exactly the details of how this is going to work mechanistically, but I think I visualize that's how it's going to be used. So.
Yeah. So the first step is just validating it and making sure that the sound science behind it.
Yeah, that's right.
Is it feasible? Does it work? And then from there on develop.
Because the potential is huge, right? If you've got millions of acres doing corn soybean and if the farmer makes the producers make some small modifications that are going to lead to less emissions and more carbon capture, that's huge, right? Mm-hmm. So the potential is there. We just got to learn and then get everyone to use it.
Our podcast is focused on water and food, as you know. We've talked a lot about the food side and kind of the ecosystem side. Is there any intersection with water management to consider when talking about carbon sequestration?
Sure. I mean, one of our fields was an irrigated field, mm-hmm. right? And I mentioned that in 2021 we broke the record of yield. We were actually doing the irrigation scheduling using our SETME model. Of course, we'd like to think that was the reason we got the record yield, but that was not the only reason, sure. right? It was a good climate year. All the things align, all the stars align. But water management was part of it, okay? And water management is important because you are making sure you're not stressing the plant in key phases. For example, at pollination, you don't want to stress corn in pollination because it'll decrease the yield. But you're also then, in our case, using precip to its maximum, right? If, we're in eastern Nebraska here, we get quite a bit of rain on a normal year. And so irrigation is used to complement that rain. And then you don't want to over-irrigate because if you do, you leach fertilizers below the root zone so they become unavailable to the plant. And then they lead to other problems, nitrate in the groundwater, right, and other problems. So proper irrigation management is important to maximize the yields, and that's where it comes into carbon sequestration.
Mm-hmm. Always all interconnected.
Yes.
So with the project entering its closeout phase, it was originally 3 years, I believe, and then was expanded to 5 years with COVID in there. And
that's right. COVID had something to do with it.
Yeah. So what happens next, and what deliverables will you have? Where will the findings be shared? What will happen next?
Sure. We have a final report due, but we also have a whole array of publications that are going to be coming out. The challenge in publishing in this area is you need more than just 1 year of data. You need multiple years of data to show that pattern and show that you're capturing carbon over that longer period. So now that we have this fantastic data set, we will be publishing. In fact, we brought all the co-PIs together earlier this year for a workshop to discuss what papers and publications and what line of research we should complete now. And that's what we're going to act on. And that's what the DOE wants us to do, is to get this into the literature so that people can learn from all this research.
So is there additional research you feel is needed, or what's kind of the big question next to solve in terms of a research question in the area of carbon?
Well, I think it's to look at different crops and different additional production systems and work towards optimizing the use of all resources that go into these production systems so that you don't over-fertilize or you don't over-irrigate. And you capture most carbon and you pollute less. And so I think that's the future which we would like to continue to work with, is continue optimizing and then getting this into the hands of the farmer, so that and that's where extension and the university comes in, is getting the message out and getting farmers to understand and use these techniques. And the carbon credits will be a bonus in the future, right? Mm-hmm. Hopefully.
Well, I think that's all the questions I have for today. I have a bunch more, but we'll save that for another time maybe, because I think that's all the time we have for today. But is there anything we didn't talk about that you want to touch on before we sign off?
I don't particularly. I think we touched all bases. The importance of this is, the equipment we're using to do these greenhouse gas measurements, nitrous oxide, methane, soil chambers, eddy covariance. It's very expensive equipment. So this is not something that the DOE or anyone's going to put out there to measure carbon credits. What we need to do is learn from all this research that was done, optimize the models, and then use that to expand in the future. So that's the final message there.
Great. Thanks for joining us today. And as a reminder, our guest today has been Christopher Neale, talking about the Department of Energy-supported effort to validate carbon sequestration in Midwestern agricultural systems and what that means for the future of carbon markets. So as the Institute, will be sharing this, your final research as it is released and comes out, and we're excited to do that and learn the specifics about the results. So thanks to all of you for listening to this Water for Food podcast. If you enjoyed the episode, please subscribe and share with colleagues and friends interested in water and food security. Until next time.
Thank you.
Thanks for joining us this time on the Doherty Water for Food podcast. Make sure to visit our website, waterforfood.nebraska.edu, to view show notes or subscribe so you don't miss future episodes.